So in these urban cars in this area, seasonality play a key role. Rainfall comes between May and October, so 90% of the rain occurring in that period means that infiltration and recharge of the shallow water table will occur over a short period of time, of a couple of months. So we found in this area that interaction of high groundwater intercepting stormwater infrastructure actually occur over a period of 160 days, a couple of months, and that is affecting the overall water quality of the area. So the water quality is affected because groundwater is contributing about 25% of the total outflow on every single storm event through the winter season, where we have the winter season and also spring when we have a high groundwater levels. So groundwater is intercepting some of the stormwater pipes, as well as can affect the base of the biofilter system, consequently interfering with the water pathway, as well as a lot of attenuation of nutrient processes occurring over that period. By looking at different storm events of different size during the winter season, the hydrologic performance or volumetric reduction of storm flow by a biofilter was affected by 30% in relation to what we were expecting from the design point of view. That 30% is just because reduction is because the groundwater was close to the base of the biofilter, so infiltration cannot take place, and consequently affecting the overall hydrologic performance of the system. So the system, even though there was a reduction on the hydrologic performance of the system was still performing well, because that reduction in performance was only momentarily for a short period of time. The implication for water quality was more complex, because that interaction with groundwater really complicated the sources of nutrient coming into the system and affected the processes, biogeochemical processes responsible for reducing nitrogen and phosphorus from the system. So over the winter period, where the groundwater was interfering with the overall performance of the system still achieved a reduction in nitrogen and phosphorus of 30 to 40%. In comparison with the time of the year where groundwater was low and the system achieved between 60 and 70% reductions. That is only for the 3 months.